Here we're going to work on the distance formula. We have the equation here at the bottom of the distance formula. The furthest x minus the closest x squared plus the furthest y minus the closest y squared. All of that square rooted will give you the distance of something. That equation seems more complicated than it really is, but you're going to see here that when you don't use anything complicated, it's a pretty straightforward equation. In the plane here on the left, we have the x and y axis highlighted in white against the yellow, and then we just have a simple straight line in red there. And we're intuitively going to just look how this works when there isn't any angle to it, when it's just basically a flat line. If we just go ahead and put this line in on the x-axis, we're going to intuitively see that it's 5. The length of it is just simply 5. But you could go ahead and use the formula to figure out, even technically, what it would be if you did use the formula. If we go ahead and we put all the numbers in, the furthest x on the x-axis is 5. The closest one is at 0. And that's for the x's. For the y's now, we have the furthest is at 0, and the closest also is at 0. So these are both just 0 and 0. So then if we go ahead and we square the 5, because that's the way our formula is set up, we get a 25. But the zeros, no matter how you work it out, the square of 0 is 0. So we have 25 plus 0 is only 25. Then take the square root of that, and we're left with 5. But we could have just seen this without using the distance formula. The distance formula is really meant to work with angles, things that are not apparently able to be seen, but this shows how the formula intuitively works, how you can just simply look at it and see that it works. Now if we introduce a line at an angle, a slanted line, we have 0.54 and we have 0.12. And we can apply this information directly into the distance formula. From this point, you're just going to plug numbers in. You have the 5, 4. You're going to bring down that 5 to be in the x2 spot. And then you're going to bring down the 1 into the x1 spot. Then you're going to go back and work with the y's now. You're going to take the 4 out of the 5, 4 and put that in the y2 spot, and then you're going to bring down the 2 and put that in the y1 spot. This is just a formula way of saying that the distance along the x-axis from the 1, 2 to the 5, 4 is 4 spaces. And then on the other side, on the y-axis, it's just trying to show you that the distance from the y2, the 1, 2, and the 5, 4 is 2 spaces. Here this can see this plugged down and portrayed a little more easily. The 5 minus 1 is 4. You can see where the 4 came from. And then you can see that the 4 minus 2 is 2, and you can see where the 2 came from. Now you're going to go ahead and square both of these values so that the 4 squared is 16 and the 2 squared is a 4. You do the normal math. You're going to get the square root of 20. So d equals the square root of 20. There's a little bit of more work that needs to be done on that, specifically that you need to take out a 4, and then that 4 needs to be reduced to a 2, and I'm going to show you why that is. Here you can see that d equals the square root of 20 is the same as d equals, at the bottom there, d equals 2 times the square root of 5. And how you do this is, in the first set right below the square root of 20, you break this down into 4 times 5 equals 20. Then break that down again, because 2 times 2 equals 4, and then 4 times 5 equals 20. This is where you're taking the 2 out, so that the square root of 4 is 2, but you can't get the square root of 5. You can't get the square root of 5 to look nice and neat, because the square root of 5 is about 2.2. And in math, specifically with doing a lot of finer calculations, you don't want about. You want the exactness of the square root of 5. You don't want about 2.2. But if you did want to simplify this down into being just a single number so that it makes better sense, and you did take the square root of 5, it would be about 2.2, so then D would equal about 4.2. But the right answer is D equals 2 times the square root of 5, which is saying approximately D equals 4.2. But in our terms and for pre-calculus and moving onward, you want to keep it in this form and not approximate.